Today in this video, we are going to implement the XGBoost algorithm, that is the extreme gradient boosting algorithms. I am taking in this implementation of the algorithms, I am taking the dataset that is the Pima Indians and diabetes dataset. You can go and download from here. And so in this data set, like we predict whether the person is having the diabetes or not. So let's get started. So I'm importing the necessary packages, that is the NumPy, and and importing the XGBoost classifier and train test field and the accuracy. So I'm also using the other models like the logistic regression, KNN, and the SVC. So we will compare the accuracy of these models with the XGBoost. So here I'm loading the model. Sorry, I'm loading the my data set, that is the diabetics data set, and then we look for like how it looks. So we have the columns like pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, and the diabetes function, and the age and the outcome, that is 0 and 1. If a person is having the diabetes, it is labeled with 1 and otherwise zeros. Then we divide the data set into the dependent and the independent variables. Here my so these are all my are the columns which are independent columns or independent variables, and the target variable is our dependent variable. So this one is the dependent variable. Then we do is we divide our this data set into the training and the testing part. So for sorry, for the training we have taken 80% of the data, and for the test we have taken 20% of the data. Okay, so in test, you can say in test we have 154 rows, and it in training, and we have 614 rows. Okay, then this is the you can say um, the logic behind. So we are I'm here making a empty list, so I will be appending all the models one by one over there. Then what we do is we take each model one by one, and we train the model, and then we make the prediction and we check the accuracy of different models. Okay, so after running this command, so we will like you will get the all the accuracy of all the models. So here you can see, so I'm getting for the logistic regression I'm getting 77%, and for the KNN it is 73%, and for the SBM it is 78%, and for the XGBoost it is coming 75%. So currently we have done nothing like you can say the feature engineering and any hyperparameter tuning. So let's do some hyperparameter tuning in the XGBoost. So here we can use the eta and the gamma values. So eta is basically how you want to aggressively and slowly you want to update the weights. And for the gamma is it is for the overfitting and like how you want to prune your trees. So let put the value of eta here equal to 0.1. So now check the accuracy. Okay, let put 0.1 here. Now it is 74%. So now you can see the accuracy of the model is increased from 74% to 78% by just making small changes in the hyperparameter on the eta value. In a similar way, we can also add gamma parameter. Like if you do the more, if you put like by default the gamma value is 0. So let's start with 10. Okay, now it is 77%. Okay, so in this way, we can tune various hyperparameters of the XGBoost. So there are, you can say, various parameters are there, and we can tune as per the business case, and we can check the accuracy.